Good morning, students. Now we shall begin with the continuation part of the probability, that is conditional probability. You know very well about the conditional probability concept, definitions, and also three important properties with solved. And also 8 problems we have solved, but 8th has been going on. Only thing, in the last class I have dictated the question carrying 5 marks of the 8th question. The question states that a die is thrown 3 times. E is an event. 4 appears on the third toss. F is another one event. 6 and 5 appears respectively on the first 2 tosses. Find the probability of E by F, conditional probability. This question carrying 5 marks. Often you will get such a question in your final examination. You should be ready to solve this without fail, without missing only one step. Descriptive question. The solution of the question is, if a die is thrown 3 times, then the number of elementary in sample space will be, because die has a 6 faces, 6 into 6 into 6, that's equals to 216. Number of sample spaces, outcomes are 216. Each sample space is designated symbolically. S is equals to first toss gives X, second toss gives Y, third toss gives Z, then E is to X, Y, Z, all are belongs to the 6 faces of the dice. 1, 2, 3, 4, 5, 6. It may be 1, 2, 3, 4, 5, 6. Each of the face will be designated by X, Y, Z respectively. Am I right here? Is it clear? First you understand the question. Here E defines an event which defines the set of events in which 4 appears on the third toss. Means each one of the event including 3 outcomes, the third outcome should be always 4. That prefers the E only. That prefers the E only. And F is the one of the event, that means the set of events in which 6 and 5 appears on the first 2 tosses respectively. 6 for the first toss, 5 is for the second toss. Means the F is an event. Second and third. So, hence, first we have to find the E. E is equals to 1, 1, 4. Because the third toss should be always condition applied here. Conditional probability, condition applied. Set of events in which 4 appears on third toss. Listen here. 1 is the first toss, another one sometimes second dice thrown, 1 appears, second toss, and third time 4 appears. It should be 4 only, you consider. Second one, 1, 2, 4. Third one, 1, 3, 4. Then there next 1, 4, 4. Then 1, 5, 4. 1, 6, 4. This is only one phase tossing of outcomes is completed here. But condition 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. First, second and third toss is not considering here. But all you observe, all in this line segment, all the third toss becomes 4 only according to the statement of the set of the event E. 4, 4, 4, 4, 4, 4. In the same manner, 6 types of the lines often you will get it. Last one is 6, 1, 2, 6, 1, 4, 6, 2, 4, 6, 3, 4, 6, 4, 4, 6, 5, 4, 6, 6, 4. Hence, entire the 216 outcomes observed here. But according to his conditions, set of sample space including 216 outcomes. According to the set of the events in which 4 appears on the third toss, either of 216, 36 outcomes belongs to the condition E, conditional of the event E, because in that condition of the probability of an event, 4 should be appear in the third toss only. We have selected 36 outcomes from a group of 216. 4 is the last, third toss element. Anywhere you check it, 4 is the last. Hence, this is the OR. Yes, 5 marks question, be aware. F is another one event. According to his statement, set of events in which 6 and 5 appears on the first 2 tosses. Means each element of each outcome belongs to the 6 and 5 in the second toss, first toss and second toss, whatever it may be in the third toss. Hence, one of the group belongs to the 3 outcomes. First one is 6, 5, 1. I have taken out from 216, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5, 6, 5, 6. Hence, only 6 outcomes, number of the 6 outcomes of the sample space of the F event, because according to the second statement of the condition applied here, 6 and 5 appears on the first 2 tosses, first and second toss, 6 and 5 respectively appeared. Then hence the F becomes, N of F is 6, number of E becomes 36. With the help of this, probability of the E is equals to number of favorable outcomes divided by total number of the outcomes. Favorable outcomes are 36. Total number of outcomes are 216, hence 1 by 6. This is probability of E, probability of an element E. In the second phase, probability of an F. F is number of favorable outcomes divided by total number of outcomes. That's equals to 6 upon 216, 1 by 36. Am I right here? Then, next what we shall continue means, after finding the event E and F, then number of favorable events from the outcomes is 36 and number of favorable events in the event F of outcomes is 6. Hence, by using these E and F, we have to find E intersection of the F. ಇದಕ್ಕೆ ಛೇದನ ಗಣ ಅಂತಾರೆ. ಗಣ ಇ ಮತ್ತು ಗಣ ಎಫ್ ದಲ್ಲಿ ಛೇದನ ಗಣವನ್ನು ನಾನು ಫೈಂಡ್ ಮಾಡಬೇಕು. ಎರಡೂ ಗಣಗಳಲ್ಲಿ ಕಾಮನ್ ಇರ್ತಕ್ಕಂಥ ಒಂದು ಗಣ ಅದ ನೋಡ್ರಿ, 6, 5, 4 is set of the event outcome 6, 5, 4 from these two events group that defines the E intersection of F. E intersection of F. Hence, E intersection of F is very important. This plays an important role to find the conditional probability value, because in the formula, in the forthcoming concept, I will show you. E intersection of F is 6, 5, 4. You should keep it in your mind. After that, we have to find the probability of an event E, that is already I had explained, 36 by 216. Similarly, probability of the event F, then that is 6 by number of favorable events are 6, total number of events are 216, hence 1 by 36. But already I I had taken out from the common elements to find the E intersection of F. We have to find the probability for this also. Hence, the probability of E intersection of F is equals to only one favorable event is there. Hence, I have kept here 1 as a numerator divided by 216 as the denominator. I have found here all together probabilities of the events E, F and E intersection of F. Very, very important question, 5 marks. After finding all these three sub-concept values, the required probability is called the conditional probability. Always conditional probability is defined by P of E by F. P of E by F. That's equals to P intersection of F divided by P of F. Why we should find E intersection F, sir? A question arised by a guy, because P intersection of the F value is very important, which is used to find the conditional probability in the formula, because conditional probability formula defines P of probability of E by F gives probability of E intersection of F divided by probability of F. Hence, P intersection of F is 1 upon 216 divided by probability of the F event is only 36. Probability of F event is 1 by 36. Probability of E intersection of F is 1 by 216 upon 1 by 36, which gives 36 upon cross multiply 36 by 216. This is the result. 1 up by 6 is the answer. Up to these steps, altogether should be clear. 100% you will get 5 for 5 out of out marks often you will get in your examination. Very, very important question. Okay. Shall I proceed for 9th question? Up to 1 to 8 questions are belonging to the 13.1 exercise chapter. Yes, along with your exercise problems as well as outside important CET concept problems, I have been solving in your problem solving process. Next question. This is also 5 marks question. Question number 9. Mother, father and son line up at a random for a family picture. Yes, mother, father, son. First, the order is very important. First place occupied by the mother, second place occupied by the father, third place occupied by the son. Line up at a random of family picture. Here E is defines son on the one end, F of the event defines father in the middle. Find the conditional probability. Find the conditional probability of P of E by F. Yes. First you understand the question once or twice. Am I right here? Then solution part. What do you understand, students? Total number of equally likely ways for placing the mother, father and son. Just now I have already cautioned you. Order is very important. First place occupied mother, second father and third son in a row. Row andre addasalu. Then first I have to find the factorial 3 ways. Total number of equally likely outcomes of the ways for placing mother, father and son. ಇವರು ಎಷ್ಟು ರೀತಿಯಲ್ಲಿ ಇಲ್ಲಿ ನಾವು ಏನದ ಮೊಟ್ಟ ಮೊದಲು ಏನು ಫೈಂಡ್ ಮಾಡಬೇಕಂದ್ರೆ ನಾವು ಪರ್ಮುಟೇಷನ್ ಮತ್ತು ಕಾಂಬಿನೇಷನ್ ಕಾನ್ಸೆಪ್ಟಿಗೆ ಬರಬೇಕು. ಇಲ್ಲಿ ಪರ್ಮುಟೇಷನ್ ರೆಫರ್ ಆಗ್ತದೆ. ಯಾಕೆ ಅಂದರೆ ತಾಯಿ, ತಂದೆ ಮತ್ತು ಮಗ 3 ಜನರು ಒಂದು ಲೈನ್ನಲ್ಲಿ ಏನದ ರ್ಯಾಂಡಮ್ ಫಾರ್ ಎ ಫ್ಯಾಮಿಲಿ ಪಿಕ್ಚರ್ ರ್ಯಾಂಡಮ್ ಆಗಿ ಕೊಡ್ತಿದ್ದಾರೆ. ಎದಕ್ಕೆ? ಒಂದು ಫ್ಯಾಮಿಲಿ ಪಿಕ್ಚರ್, ಫ್ಯಾಮಿಲಿ ಫೋಟೋನ ಏನದ ಗ್ರ್ಯಾಬ್ ಮಾಡಲಿಕ್ಕೆ. ಆದರೆ ಈಗ ಒಮ್ಮೆ ಮೊದಲೇ ಸ್ಥಾನದಲ್ಲಿ ತಾಯಿ ಇರ್ತಾಳೆ, ರ್ಯಾಂಡಮ್ಲಿ ಚೇಂಜ್ ಆದಾಗ ಮತ್ತೆ ಅದು ಏನದ ಮಗ ಬರ್ತಾನೆ, ನಂತರ ತಂದೆ ಬರ್ತಾನೆ, ತಾಯಿ ತಂದೆ ಮಗ, ತಾಯಿ ತಂದೆ ಮಗ, ಹಿಂಗೆ ಸುತ್ತ ಹಾಕೋದು ಬರ್ತಿರ್ತವೆ. ಆದರೆ ಇಂಥ ವೇಳೆಯಲ್ಲಿ ನನಗೆ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ದಿ ಇವೆಂಟ್ಸ್ ಎಷ್ಟು ರೀತಿಯಲ್ಲಿ ಇದನ್ನು ನಾವು ಈ ಫೋಟೋವನ್ನು ಈ ರೀತಿ ನಾವು ಕ್ಲಿಕ್ ಮಾಡ್ಬೋದು. ಮೊದಲೇ ಪ್ಲೇಸ್ ಮದರ್, ಎರಡನೇ ಪ್ಲೇಸ್ ಫಾದರ್, ಸನ್, ಮೂರನೇದು, ಇದು ಒಂದು. ಆಮೇಲೆ ಮುಂದೆ 1ನೇ ಪ್ಲೇಸ್ನಲ್ಲಿ ಸನ್ನು, 2ನೇ ಪ್ಲೇಸ್ನಲ್ಲಿ ಫಾದರು, 3ನೇ ಪ್ಲೇಸ್ನಲ್ಲಿ ಮದರು, ಆಮೇಲೆ ಮತ್ತೆ 1ನೇ ಪ್ಲೇಸ್ನಲ್ಲಿ ಫಾದರು, 2ನೇ ಪ್ಲೇಸ್ನಲ್ಲಿ ಸನ್ನು, 3ನೇ ಪ್ಲೇಸ್ನಲ್ಲಿ ಮದರ್. ಹೀಗೆ ಇದು ರ್ಯಾಂಡಮ್ ಏನದ ವೇರಿಯೇಷನ್ ಅಂತಾರೆ. ಹೀಗೆ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಅಲ್ಲಿ ಕ್ರಮಯೋಜನೆಯನ್ನು ನಾವು ಏನದ ಪರಿಷ್ಕರಣೆಯಲ್ಲೇ ಮಾಡಲೇಬೇಕು. ಆ ಕ್ರಮಯೋಜನೆಯನ್ನು ಪರಿಷ್ಕರಿಸಿದಾಗ ಮಾತ್ರ ನನಗಲ್ಲಿ ನಂಬರ್ ಆಫ್ ವೇಸ್, ಇನ್ ಹೌ ಮೆನಿ ವೇಸ್ ಮದರ್, ಫಾದರ್, ಸನ್ ಕ್ಯಾನ್ ಬಿ ಸೀಟೆಡ್ randomly in a row. Yes, to find this, so I have used here permutation. Do you know definition of the permutation and combination? Already you have studied in earlier class. ಕ್ರಮಯೋಜನೆ ಅಂತಾರೆ. ಒಂದು ವಸ್ತುವನ್ನು ನಾನು ವ್ಯವಸ್ಥಿತವಾದ ಕ್ರಮದಲ್ಲಿ ಯೋಜಿಸುವಂಥ ಒಂದು ವಿಧಾನಕ್ಕೆ ನಾವು ಪರ್ಮುಟೇಷನ್ ಅಂತೀವಿ. The systematic arrangement of the numbers, arrangement of the words, arrangement of the letters in a systematic manner, that is called permutation. This is the definition of the permutation. Am I right here? So why we should use that permutation here, sir? One of the question arised by a student. Then what may be answer means the permutation is very important here to find the total number of the ways, like sample space here. Instead of sample space, we have found here the total number of the ways by using permutation concept. Am I right here? Total number of equally likely ways for placing the mother, father and son in a row can be, according to the random sitting arrangement, that's equals to factorial 3. ಯಾಕಂದರೆ 3 ಜನ ಇದ್ದಾರೆ, ಅವರನ್ನು ನಾನು 3 ಜನರನ್ನು ಎಷ್ಟು ರೀತಿಯಲ್ಲಿ ನಾವು ಕೂಡಿಸ್ಬೋದು ಅಂದಾಗ ಫ್ಯಾಕ್ಟೋರಿಯಲ್ ಸಿಂಬಾಲನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಫ್ಯಾಕ್ಟೋರಿಯಲ್ n ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು n into n minus 1 into n minus 2 ways. Am I right here? Already you recalled your previous class memory. Factorial 3 equals to 3 into 2 into 1. n means 3, n minus 1 means 2, n minus 2 means 3, 1, hence 3 into 2 into 1, which gives 6 ways. Am I right here? First step is over. You will get here only 1 mark. Next, to find the event E, but we have to select them. E event defines here according to his statement, sun on one hand, yes, he may sit in the first or in the last. From total number of the 6 ways, sample space is here, instead of the s, 6 ways, 6, either of the 6, sun, in how many ways sun sit one end, in how many outcomes, in how many number of the outcomes, we have to select here sun only sit at the one end. He may sit in the first or he may sit in the last. Here yes means son, mother, father. Here son, father, mother. Here mother, father, son. Here father, mother, son. Only 4 outcomes, 4 number of the outcomes available. The only son sit in the first or in the last place, because E is an event defines sun on one end. Sun on one end. Am I right here? Then F is another one event defines father should be always in the middle. Father should be always in the middle. Means F means father always middle means only two outcomes happened here. One is SFM, either of 6. 4 already I have selected because son is one end. But second, if FE event states that father should be always in the middle place, either of the left and right, maybe son or maybe mother. But here in the first outcome, SFM defines first place son, father is in the middle, third place mother. Here the first place mother, father is in the middle, third place son. So in this manner, only two outcomes often you will get in the F event. Hence, number of the events, total number of the events in the E is equals to defined by N of E, 1, 2, 3, 4. Students, listen here. How many outcomes often I get it? Only 4 outcomes from the event E. This is called the N of E, which is the sample space N of S, like this, comparing to the probability concept of with related with permutation. Similarly, in the F, N of F is equals to 2. This is very important to find the probability of E and F. Total is 6 ways. Am I right here? Is it understand? 1 minute, once again you observe the question and first 3 steps. Up to this you will get only 3 marks. Up to this you will get 3 marks. Yes, because sample space of E is equals to 4. Sample space of F is equals to 2. The finding of the sample space in the question number 8 and question number 9 is differ. In question number 8, only commonly we have taken the, according to probability concept, to find the sample space N of S directly. N of S directly. Here, instead of this N of S taking directly, here we use the permutation concept. Why? Because the arrangement of the father, mother, father, son, 3 persons arrangement in a different manner with randomly. Hence, it is different. So, very, very important questions 8 and 9, according to mine. Because here, finding the sample space, different manner. In this case, the sample space is entirely depending upon the permutation concept. In the earlier question, 8th question, the sample space is depending only on the S, N of S. Here, N of E equals to 4 because 4 outcomes from the event E. N of F equals to 2 outcomes from the event F. With the help of this, I have to find the probability of an E, probability of an E, probability of an F. Yes, probability of E is equals to common formula probability apply, number of favorable events divided by total number of events. Number of favorable events means N of E, always N of E. She defines number of favorable events, that is equals to 4. And total number of event means by using the permutation concept 6. Here 6 ways. 6 ways mother, father, son can sit. So I have used here 6 as a denominator. This is the N of S here. You understand clearly. Am I right here? Then 4 by 6 gives 2 by 3. Similarly, probability of F is 2 by 6 because only 2 outcomes I got from N of F. N of F is the sample space of the outcomes from F only, that is 2. Yes, then okay. Yes, after finding the N of E, N of F, then must and should we have to find probability of E, probability of F. Without these two, it is impossible, highly impossible to find the conditional probability, required conditional probability. After this, n of E and F, therefore n of E intersection F, n of E intersection F. N of E intersection F means I have to search here what are the common outcomes from the set of E and F. What are common outcomes here? SMF, SFM, MFS, FMS. What are SFM is one outcome. This is common. Common means ಈದಲ್ಲಿನೂ ಇರಬೇಕು, ಅದು ಎಫ್ ದಲ್ಲಿನೂ ಕೂಡ ಇರಬೇಕು. ಇವುಗಳಿಗೆ ನಾವು ಸಾಮಾನ್ಯ ಏನದ ಘಟನೆಗಳು ಅಂತೀವಿ. ಇವುಗಳಿಗೆ ಏನದ ಔಟ್ಕಮ್ಸ್ ಅಂದ್ರೆ ನಮಗೆ ದೊರೆತಂಥ ಘಟನೆಗಳು. MFS ಇಲ್ಲಿನೂ ಅದ. ಅದಕ್ಕೆ ಇವು ಎರಡು ಘಟನೆಗಳು ಏನದ ನೋಡ್ರಿ, ಇವು ಸಾಮಾನ್ಯವಾಗಿದ್ದಾವೆ. ಇ ಮತ್ತು ಛೇದನ ಎಫ್. ಮೊದಲು ಇಲ್ಲಿ ಎಫ್ ಪಿ ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಇ ಆ್ಯಂಡ್ ಎಫ್ ಎಷ್ಟು ಬಂದು ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲೊಂದು ಮಾರ್ಕ್ ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ ನಾ ರೆಡ್ ಇಂಕ್ಲೆ. ಇದು ಒಂದು ಕಾಮನ್ ಇದೆ, ಇದು ಒಂದು ಕಾಮನ್ ಇದೆ, ಇದು ಒಂದು ಕಾಮನ್, ಇದು ಒಂದು ಕಾಮನ್, ಇದು ಒಂದು ಕಾಮನ್. ಅಂದರೆ ಎನ್ ಆಫ್ ಇ ಇಂಟರ್ಸೆಕ್ಷನ್ ಎಫ್. ಇದು ಇವು ತೆಗಿಲಾರ್ದೆ ನಿಮಗೆ ಈ ಆನ್ಸರೇ ಬರುವುದಿಲ್ಲ, 5 ಮಾರ್ಕ್ಸ್ ಸಿಗೋದಿಲ್ಲ. 100% ಇದು ಒಂದು ಕ್ವಶನ್ ಬರ್ತಾ ಇಂಥದ್ದು. ಎನ್ ಆಫ್ ಇ ಇಂಟರ್ಸೆಕ್ಷನ್ ಎಫ್ ಈಕ್ವಲ್ಸ್ ಟು 2 ಎಲ್ಲಿದು ಬಂತು ರೀ ಸರ್ ಅಂದರೆ ಇ ಮತ್ತು ಎಫ್ ದಲ್ಲಿರ್ತಕ್ಕಂಥ ಸಾಮಾನ್ಯ ಘಟನೆಗಳು, ಕಾಮನ್ ಎಲಿಮೆಂಟ್ಸ್, ಕಾಮನ್ ಔಟ್ಕಮ್ಸ್ ಹಿಯರ್. ಸೊ ಎನ್ ಆಫ್ ಇ ಇಂಟರ್ಸೆಕ್ಷನ್ ಎಫ್ ಈಕ್ವಲ್ಸ್ ಟು 2. ದೇರ್ಫೋರ್ ಇದ್ರದ್ದು ಪ್ರೊಬೆಬಿಲಿಟಿನೂ ತೆಗಿಬೇಕು. ಐ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ದ ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಎನ್ ಆಫ್ E intersection F, that's equals to probability of E intersection F gives E2 divided by total number of rays 6, 2 by 6. Altogether concept of the conditional probability I found. Finally, required conditional probability designated by probability of E by F is equals to probability of E by F upon P of F. Probability of E intersection F upon probability of F. ನಾನು ಯಾಕೆ ಈ ಇಂಟರ್ಸೆಕ್ಷನ್ ಈ ಟರ್ಮನ್ನು ಫೈಂಡ್ ಮಾಡಬೇಕು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯಿತು. ಕಂಡೀಷ್ನಲ್ ಪ್ರೊಬೆಬಿಲಿಟಿಯಲ್ಲಿ ಇದು ನಿಮಗೆ ತೆಗಿಲಾರ್ದೆ ಆನ್ಸರ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ದಿಸ್ ಈಸ್ ದ ಕಂಡೀಷ್ನಲ್ ಪ್ರೊಬೆಬಿಲಿಟಿ ಫಾರ್ಮುಲಾ. Probability of E upon F gives probability of E intersection of F divided by probability of F. Why we should find, sir, probability of E intersection F without finding the intersection of the events? Impossible to find the conditional probability value. So 2 by 6 upon P of F means individually I have found here probability of F 2 by 6 which gives 1. Always probability defines here in the whole numbers, sometimes maybe fractions also. Here it defines 2 by F upon 2 by 6 upon 2 by 6 which gives 1, which is the required conditional probability. Am I right here? 9th answer is over. Okay. Welcome back. The question number last. This carries 5 marks in your final examination. 10th question on the conditional probability. Okay. Very carefully listen. The 10th question states that assume that each born child is equally likely to be a boy or girl. Friend students, you cannot predict a born child may be girl or boy without saying. But here he states that assume that each born child is equally likely to be a boy or girl. If a family has 2 children, what is the conditional probability that both are girls given that condition 1 applied, the youngest is girl. Both are girls, but youngest is girl. And second condition applied here, at least one is a girl. Yes, read the question once or twice. The solution: a family is there, 2 children are there. I have to find the sample space of the children. What the condition applied here? Family has only 2 children, maybe boy or girl. What is the condition? That both girls, given that the youngest is a girl, and second condition applied here, at least one is a girl. First, I have to find the sample space of the boy and girls. B defines here boy, G defines here girl, B defines boy, G defines girl. I have to find the sample space. S is equals to B, B. Two children I have taken at one outcome. Condition: 2 ಮಕ್ಕಳನ್ನು ನಾನು ಒಂದು ಬಾರಿ ಒಂದು ಔಟ್ಕಮ್ ಅಂಡ್ ಗ್ರೂಪ್ನಲ್ಲಿ 2 ಮಕ್ಕಳು ಇರಬೇಕು. ಅದು ಮೊದಲೇ ಸಲ ನಾನು ತಗೊಂಡಾಗ 2 ಗಂಡು ಮಕ್ಕಳೇ ಇವೆ. ಎರಡನೇ ಸಲ ತಗೊಂಡಾಗ ಮೊದಲೇದ್ದು ಬಾಯ್, ಎರಡನೇದ್ದು ಗರ್ಲ್. ಮೂರನೇ ಸಲ ತಗೊಂಡಾಗ ಮೊದಲೇದ್ದು ಗರ್ಲ್, ಎರಡನೇದ್ದು ಬಾಯ್. ಇನ್ನೊಮ್ಮೆ ನಾನು ಸೆಲೆಕ್ಟ್ ಮಾಡಿದಾಗ 2 ಗರ್ಲ್ಸ್ಗಳು. ಆದರೆ ಒಂದು ಔಟ್ಕಮ್ ಗ್ರೂಪ್ನಲ್ಲಿ ಕನಿಷ್ಠ 2 ಗರ್ಲ್ಸ್ಗಳು ಇರಬೇಕು. ಬಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಹೀಸ್ ಗಿವನ್ required statement, the first one we shall be begin, the youngest is girl. Youngest is girl. Let E be the event that both children are girl. According to here, both children are the girl. But one thing is condition applied, youngest is girl. So you consider here E is one of the event. That event defines that both the children are girls, means G. Here n of E equals to only 1. Am I right here? N of E equals to only 1. But what is the second one? F is an event that the youngest is a girl. Youngest child is a girl. Means at least one is a girl, it may be, but youngest child is the girl. Means I have taken here the according to his statement G, B, G, G, because in either of the only 4 is the n of S, because 4 outcomes are there. One boy, second also boy. In the second outcome, first outcome boy, second outcome is the girl. Here G and B, G. But according to youngest child is the girl, means I have taken here first as a youngest, then child is the girl, means one is G, second one may be boy. Second time the first one is the G, second time also girl. Yes, welcome back. There is a small correction. In the event F defines event that youngest child is a girl, means first maybe boy or younger child is a girl, and here eldest child may be girl, youngest child may be girl. So here 2 outcomes from the second statement of the event F. Here 1 outcome from the first statement of the event. Either of these 2, E and F, again I have to find E intersection of F. E intersection of F. This is very common to find the conditional probability G, G. Here also, this is the common element from E and F here. So E intersection is G comma G. Now, according to the required conditional probability of E by F is equals to probability of E intersection F by probability of F. Means E intersection F means only 1 by 4 upon probability of F is only 2 by 4. F means here 2, n of 2, n of F equals to 2. N of E equals to 1. So 1 by 4, total are 4 here, n of S. So 1 by 4 upon 2 by 4, which gives 1 by 2. This is the first sub question. Youngest is a girl. One more question is there. The second sub question states that let E be the event that both children are girl. This is the common. Let E be the event both children are girl. This is the common event for both the sub questions. So if at least one child is a girl, at least means girl, two childs are there, or two children are there, or two boys are there, or two girls are there, but at least in a group of outcome, one may be a girl, one child may be a girl. So F is the event that defines event that at least one child is a girl. Means I have to select from the sample space of random experiment. What the random experiment defines here, the sample space. Well-defined collection of the objects, well-defined collection of the outcomes from the set of sample space that defines the set of sample space. So S is equals to 4 outcomes are there. Either of 4, I have to select condition applied. At least one is girl. The first outcome is not favorable here because both child belongs to these both children belongs to the boys exited. Then second one is favorable. At least one is girl, one is boy. Here first is girl, second one is boy. Third, both are girls. Means 3 outcomes are favorable to the event that at least one child is girl. B comma G, G comma B, G comma G. Event E, event F, both are very important here. Here n of E equals to 1, n of F equals to 3 here. 1 minute. Wait for 1 minute. I have to write down. N of E is equals to 1 because only one outcome is there. Here n of F is equals to 3 because 3 outcomes are there. Am I right here? Therefore, with the help of these E and F events, then I have to find E intersection of F. E intersection. This is essential to find conditional probability. Therefore, E intersection F equals to G comma G. G comma G. That's equals to. Then, with the help of this and intersection n of F, I have to find the probability. Now required conditional probability is equals to P of E intersection F upon P of F. That's equals to 1 by 4. How do you get 1? Because E intersection F defines only one outcomes. Therefore, total number of probability of n of E intersection F ನೀವು ಫೈಂಡ್ ಮಾಡಬೇಕು. ದ್ಯಾಟ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 upon 4. ಇಲ್ಲಿ ಒಂದೇ ಒಂದಿದೆ, ಅದಕ್ಕೆ ಫೇವರೇಬಲ್ ಇವೆಂಟ್ ಈಸ್ ಓನ್ಲಿ 1, ಅದಕ್ಕೆ ಇಲ್ಲಿ 1 ಬರದೆ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಆಫ್ ಎಸ್ ಅಂದ್ರೆ ಇಲ್ಲಿ 4 ಇದ್ದಾವೆ. ಎಸ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 4 ಇವೆಂಟ್ಸ್, ಅದಕ್ಕೆ ಇಲ್ಲಿ 4 ಬರದೆ ಎನ್ ಆಫ್ ಇ ಇಂಟರ್ಸೆಕ್ಷನ್ ಎಫ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 upon 4. ತಿಳಿತೋ ಇಲ್ಲೋ? divided by n of f is equals to, ಇಲ್ಲಿ n of f 3 ಅವ, ಇದ್ರದ್ದು ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಎಫ್ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಇದು ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಎಫ್ ಏನು ಕೊಡ್ತದಂದರೆ 3 ಡಿವೈಡೆಡ್ ಬೈ 4 ಕೊಡ್ತದೆ. ಆದರೆ ಇದು ಪಿ ಆಫ್ ಎಫ್ P of E intersection F divided by P of F is the conditional probability of P of E by F. 1 by 4 divided by 3 by 4 is equals to 1 by 3. This is the final answer. Hence, up to this I have completed very important problems based on the conditional probability along with the theory part as well as problem solving part. And next I have given here the 11th and 12th is the homework problem. 1 minute. 2 questions I have given the homework, that is 11 and 12. I will give you the homework. Today you try to solve these 2 important questions from NCERT also. All of you read the homework problems, homework questions. Yes, okay. Once again, you read it. The homework problems, the 11th, 2 numbers appearing on throwing 2 dice are different. 2 numbers appear while we are throwing 2 dice. 2 numbers appear. Find the probability of the event, that is the sum of the numbers, means sum of the 2 numbers on the dice is equals to 4. ಮೊದಲೇ ಡೈ 3 ಇರ್ಬೋದು, ಎರಡನೇ ಡೈ 1 ಇರ್ಬೋದು, ಮೊದಲೇ ಡೈ 1 ಇರ್ಬೋದು, ಎರಡನೇ ಡೈ 3 ಇರ್ಬೋದು, ಮೊದಲೇ ಡೈ 2 ಇರ್ಬೋದು, ಎರಡನೇ ಡೈನೂ 2 ಇರ್ಬೋದು. ಆದರೆ ಇದನ್ನು ಕೇಳಿದ್ದಾನೆ, ಇದು ಕೂಡ 5 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಇದೆ. ನೀವು ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಿರಿ ಮನೆಯಲ್ಲಿ. ಎರಡನೇದೊಂದು ಏನದು 1 ಮಾರ್ಕ್ ಏನದ ಅಬ್ಜೆಕ್ಟಿವ್ ಟೈಪ್ ಕೇಳಿದ್ದೀನಿ. ಇಫ್ ಪ್ರೊಬೆಬಿಲಿಟಿ ಆಫ್ ಎ ಈಸ್ 1/2 but probability of B is 0, then what is the conditional probability of A by B? Conditional probability of A by B. What is the conditional probability of A by B? Options given, very skill question. First option is 0, second option is 1/2, third option is not defined, fourth one is 1. This is 1, you consider 1. Yes, students, now I am going to wind up your class. Next class again in the next week, this Friday or Saturday, I will give you the next new concept of the probability. Only 3 units for your syllabus according to the COVID new concept of the syllabus. First one is the conditional probability, second one is the Bayes theorem, and next one is the third last part. So in the next class I shall begin with the Bayes theorem of the probability concept. Up to the 10 questions and 2 homeworks I have given. In forthcoming Saturday we shall begin the new concept. Okay, all the best. Thank you.